Okay, so the next example that we're going to be discussing is the OR example. So just like what we did before, we're going to solve each of them individually, draw the graph, and see where the OR happens. So in the top part, we multiply both sides by 2. So that we get 3 times 2x plus 4 is greater than or equal to 10. And then divide both sides by 3. These cancel, and you're left with 2x plus 4 is greater than or equal to 10 over 3. Now, you can do it this way. I think it's actually fairly difficult. This is just the first thing that popped into my mind. So what I'm actually going to do is I'm going to distribute it instead. So let's distribute this 3 as 6x plus 12 is greater than or equal to 10. And then now subtract 12 to both sides. So 6x is greater than or equal to negative 2. And then go ahead and divide by 6. Okay, so this right here is negative 2 over 3 times 2. So those cancel, and we're left with negative 1/3. Now do it for the other side. I'm going to erase this just so we have more space. I'm going to bring the 2x over. So we have x plus 1 is less than 5. And then subtract the negative 1. So x is less than 4. Now it doesn't matter if you bring the x's over to the left or to the right. It's just a personal preference that I keep them on the left. And I think it's easier if you make a uniform way of doing things. So I always bring x over on the left-hand side. So the next step, once you have both of these two, is to draw the graph. So let's draw it on the number line. There's 4, and negative 1/3 is right about there. So x is less than or less than 4 is to the left of 4. And x being greater than or equal to negative 1/3 is to the right of negative 1/3. It should be right. And or equal to at that point. Now, before you write your answer, don't forget, this is the key. So it's in one, the other, or both. So this section right here to the left is in one. This section to the right, if I extend it out a little bit more, is in the other. And right in the middle is where both happens. And notice that there's nothing that's not there. So this contains all the numbers, or from negative infinity to infinity. Okay. The next example is very similar, but you'll see a different answer. So this one has 3p plus 2 is less than or equal to 5, or 5p minus 7 is greater than or equal to 8. So similarly, let's go ahead and solve each one separately. So we get 3p is less than or equal to 3, so p is less than or equal to 1. And then the right-hand side, if I add 7, we get 5p is greater than or equal to 15, and then divide by 5. So again, once you hit this point, you get the p's by themselves or the variables by themselves. Draw it on a number line. So the one on the right is blue. So greater than or equal to 3. Just that way. And then the one on the left will be red, which is less than or equal to 1. Now, or, remember, is 1, the other, or both. So does everyone see that this is in 1, and this is in the other? And there is no both. So the part that's in 1 starts from the left, read from the left, from negative infinity, hits 1. And it's included because it's closed. We always join it with a union from the 3 to infinity. And again, this is also closed because it's a closed knot. Now, be very specific, okay, because if this was an AND problem, there is no overlap, right? We just said here there's no both. So if this was an AND problem, there would be no solution here. So you have to be very specific about understanding that this is the key that you need to bring down here, which tells you whether to look for 1, the other, or both, or just the both part.